All right, so now that we've thought about the preliminary example, let's look at the first example on this 3.1. So for this example, we want to find the absolute maximum and absolute minimum values of the function given algebraically, so without a graph, on the interval from 1 to 4. So as we saw in that preliminary example, what we need to do is check the function value on endpoints and critical points. And when I mean check, I mean compute the output values of f and see what output value is larger. So let's do that. So endpoints, we're first just going to find all the values that we're going to compute f on. So the endpoints include the endpoints of my interval from 1 to 4. So that would be x equals 1, x equals 4. And then we need to find the critical values or points. So to do that, we need to compute the derivative of f of x. So there we can just use the power rule. And let's just recall that if we have a term like 3 over x, that's equal to 3x to the negative 1. So we take to the derivative, we're just using power rule there also. So the derivative of f is just going to be 1 and then minus 3 over x squared. Feel free to pause the video and just check that derivative. Make sure you're comfortable computing that derivative. And then now we can just simplify this further. So if I want to add these two numbers together, I can't do it in their current form, but I can change this 1 to have a denominator of x squared. To do that, I have x squared over x squared. That's the same thing as 1. So I can rewrite 1 that way, and then I subtract 3 over x squared. Now I can combine these two fractions with the same denominator, x squared minus 3 all over x squared. All right, so there we have our derivative. So now we need to check where is the derivative equal to 0. So that means I want to set x squared minus 3 over x squared equal to 0. Oh, and let's also recall, we want to know where or what x values the derivative is undefined. So we have those two options. So x squared minus 3 is equal to 0. That happens when the numerator is equal to 0. So that would mean x squared is equal to 3. So then x is equal to plus or minus the square root of 3. But then we also have where x squared minus 3 over x squared does not exist. That happens wherever the denominator is equal to 0, because recall we can't divide by 0. So that would mean x squared is equal to 0, which would mean x is equal to 0. So now we have identified our critical values. So let's test the outputs of our critical values with our endpoints to see what value is larger. So now we're going to compare f outputs to determine the largest or the max and the min. So I'm going to put my x values here and my f of x values here, so we can create a nice table to compare those outputs. So if we gather our values here, we have our two endpoints, 1 and 4. Then we have square root of 3, negative 3, and 0. Ooh, let's notice that negative root 3 and 0, those are not in interval. They're not in the interval from 1 to 4. So we don't need to check them because we only want to know about the absolute max and min on this interval from 1 to 4. All right, so let's set this up. So we have our point 1, we have our point root 3, and we have our point 4. So let's go ahead and check the output values for those 3 points. So we're computing f of 1, f of root 3, and f of 4. So that looks like 1 plus 3 over 1. That looks like root 3 plus 3 over root 3. And 4 plus 3 over 4. So you can get out a calculator and compute all those values. And go ahead and check my work here. I'm getting 4. And then here I'm getting about 3.46. And for this last problem, I'm getting 4.75. So based on these outputs, which number would you say is the absolute max? Awesome. You should be seeing absolute max as happening when x is 4, the output is 4.75. Then the absolute minimum occurs here when the output is 3.46. So how we'd write our answer is the following. So the absolute maximum, I'll write this out first. Absolute maximum, we could say it occurs when x equals 4, but the maximum itself is the output. So it is the f of 4, which is 4.75. So that's the largest our function is going to get on the interval from 1 to 4. And then the absolute min it occurs when x is equal to root 3, but the actual minimum itself is f of root 3, which is about 3.46. All right, great work, everyone. Now you have a few more exercises and examples to look at in this section. Please take your time going through these problems, watching these videos. Keep up the hard work.